All right, so we're moving on to different kinds of variation and problem solving embedded in those. Uh, so let's just jump right into it. Usually, well, I shouldn't say usually, it's always. When you see y varies directly as x, that means we're following the equation on the form y equals kx. In other words, direct variation or directly proportional, things like that, means that it's a line that goes through the origin. So sometimes when teachers teach this or students learn it, they think about, well, if y is 5 when x is 30, then they can come up with the slope as if it goes through the origin and then come up with a problem from that. Otherwise, what people might do is take this equation and say, okay, well, y is 5. We need to figure out what k is when x is 30. Well, then we could divide the 30 over and then reduce, because both those numbers are divisible by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. So then we could say that the equation is y equals 1, 6x. Up 1, right 6. And if we kept going up 1, right 6, when we get to y is 5, we would get to x is 30. So everything I've said has been true so far. By the way, this k value is called the constant of variation. And then this is the equation. So let's move on. If we have an inversely proportional relationship, that means as inverses go, it's going to be like a reciprocal function. So instead of y equals kx, well, in this time it's b instead of y. I almost wrote down y again. It's b equals k over a. So in this case, it doesn't even go through the origin because the a value, because this is the a axis, it's like the b axis. Anyway, the equation looks more like this, or the graph looks more like that if you use Desmos or some other graphing calculator. So k is still the constant of variation. So with that, we would set the problem up as 5 equals k over 9. So you'd multiply the 9 over. My a's and 9's look the same. I'm sorry, this is a 9, this is an a. Try to put more of a loop on there. Anyway, multiply the 9 over, and the constant of variation would be 45. So then the equation would be b equals 45 over a. And that's the equation that I'm looking for. That's an a. Until, because I loop my a a little bit more. Sorry about that. Anyway, let's move on to the next one. The area, oh, you might notice I've skipped exercises, I think, because in the book, I shut my book already. I think they more are looking at graphs, and that's not really something I'm going to test you over. So I usually teach these videos based off the test. Be ready for anything I talk about could show up on the test, but not necessarily anything that's in the book. Anyway, moving on. The area of a regular polygon varies jointly. Okay, so joint variation, that's a new one. That's direct variation with more than one variable. So direct variation is of that form y equals kx. Well, now it's just going to be like y, or that was in, I wrote down a and I said x. Now it'd be something like y equals kxy. So not y. I am struggling right now. It's been a long day. Anyway, like this would be y varies jointly to x and z, the way I have it written there. Okay, so the area of a polygon, A, is it varies jointly, so k, and then as the apothem and its perimeter, so AP. Oh, I guess that's all we had to do. Now, if anybody looks it up, like if you Google the area of a regular polygon, what you'll actually see is the formula is area equals 1/2 apothem times perimeter. So the constant of variation is actually 1/2 in that problem. So if anybody were to write this down, I'd give them full credit, but all I'm looking for is this boxed equation, by the way. Okay, so we can look at even more stuff. So remember, inversely proportional means k over whatever variable. So in this problem, it'd be y equals k over the cube of x. So it's not just x, it's going to be x cubed. So this is how we're setting up the problem. Well, now what we have to do is actually solve it. So if y is 1/2, when x is 2, okay, well 2 cubed is 8, so to get rid of 8, we're going to multiply both sides by 8. Well, half of 8 is 4, so the constant of variation is 4, as the direction said, and the equation, if I go back to it, would be y equals 4 over x cubed. That's what I want. And hopefully this is all making sense. Otherwise, I'm going to assume that you're pausing the video and rewatching. And if you're not doing that, you should be writing down your equations. You should be writing down your questions and bringing your questions to class to ask me. Whew. I'm going to eventually get through this. In the next exercise, they give you a direct variation and an inverse variation. So what that means is our equation is set up as y equals k times z. There's the direct relationship. And inversely as the cube of x. So inversely means x is going to be in the denominator. So all we're doing is we're doing a combination of variations. We can have direct and inverse in the same problem. So let's set it up as y is 15. We don't know k yet. That's what the constant of variation is. We'll solve that. When z is 5, and so let's replace z with 5, and x is 3 cubed. Now what I would do is first divide by 5. So 15 divided by 5 would give me 3. And then multiply the 3 cubed over. And then that would tell me that k would equal 81. So our equation would be y equals 81z over x cubed. Okay, so I do realize that I'm not really slowing down and reworking things. I'm just sort of going through, and I'm going to trust you to do this. So there's really only three things. Let's summarize it for you. By the way, I haven't been assigning reviews to you guys, so you just have your homework assignment. So direct variation is y equals kx. Inverse variation would be y equals k divided by x. And then joint variation just means direct for more than one. So it'd be like y equals k x z. And we can do a combination of things, like we could vary jointly with 2 variables and inversely with a third. So be ready for any of those in this homework assignment, and you should be ready for to get that done. If you still have questions, feel free to bring them to class. I'd love to answer them.